Hello children, welcome back to my channel. I am now dealing with ninth class maths, exercises 7.2 in triangles. Third problem, two problems I have already done. Third one is triangle ABC is an isosceles triangle in which altitudes BD and CF are drawn to equal sides AC and AB. These two are equal sides. You have to show that the altitudes are equal. So, what is given to us in triangle ABC? AB is equal to AC and altitudes BD and CE. BD is perpendicular to AC, CE is perpendicular to CF. CF, BD and CE. This is not F, CE. CE is perpendicular to AB. Now, what is that you need to prove? You have to prove that the question is you have to prove that altitudes are equal. That is, BD is equal to CE. You have to prove. Now, let us see the proof. Let us take triangles in triangle BCE and triangle BCD. BCE and BCD. In these two triangles, in BCE triangle you have angle B. That is angle B is equal to, and in BCD triangle you have angle C. They are equal. Why? Because AB is equal to AC. See, in this triangle AB is equal to AC means these two angles are equal. Angles opposite to equal sides are equal. We have learned the theorem. And what else we can say? BC is equal to BC. This is common. And also angle E. For BCE, angle E is equal to angle D 90 degrees. Therefore, triangle BCE is congruent to triangle BCD basing on what is this? This is angle, this is side, angle, angle, side. Angle, angle, side property. Angle, angle, side. This is also right angle, no? So, angle, angle, side property. Therefore, what you can say? BD is equal to CE. Hence, proved. So, what is given to us? ABC is an isosceles triangle. That means in triangle ABC, AB is equal to AC they have given, and BD is perpendicular to AC, C is perpendicular to AB. Now we need to prove that BD is equal to CE. Now let us take triangle BCE and BCD. In this angle B is equal to angle C because AB is equal to AC. And BC is equal to BC common for these two triangles. Angle E is equal to angle D 90 degrees. Therefore, these two triangles are congruent basing on angle, angle, side property. When these two triangles are congruent, BD is equal to CE. This is the proof for this problem, children. Please note it down. Now, fourth problem, children. In this problem, ABC is a triangle in which BD and CE are two sides AC and AB. These are altitudes BD and CE to the sides AC and AB are equal. Means these two are equal. What is given? In triangle ABC, BD is perpendicular to AC, CE is perpendicular to AB, and BD is equal to CE. This is given to us. Okay. Now, what is RTP? You have to prove that first bit. Triangle ABD is congruent to triangle ACE. and second bit AB is equal to AC. That is ABC is an isosceles triangle. This you have to prove. So let us go for the proof. Proof is two triangles. In triangle ABD and triangle ACE. See, ABD is one triangle and ACE is another triangle. In this figure, they have even given a line like this. This line also is given to us in this figure in the book. Okay. In triangle ABD is one triangle. ACE is another triangle. So if this is not there, then we can very well say in ABD angle A is there, in ACE is also angle A is there. Angle A is equal to angle A, it is common. Both the triangles are having same common angles. And what else? They said BD is equal to CE. BD is equal to CE. This is given to us. BD is equal to CE, you have got. And what else you can say? See children, ABD. ABD. In triangle ABD, angle D. And in triangle ACE, angle E. Angle D is equal to angle E, 90 degrees. Therefore, triangle ABD is congruent to triangle ACE basing on angle side property. Two angles and a side. This is one angle and this is one angle, this is one side. Angle side property, these two are congruent. So this is for the first proof. Now second proof. They are asking AB is equal to AC. We have proved that triangle ABD is congruent to triangle ACE. It is proved just now. Triangle ABD, triangle ACD. These two triangles are congruent means AB is equal to AC. Therefore, triangle ABC is an isosceles triangle. Hence, proof. This is the proof, children. Once again, they have given triangle ABC in which BD is perpendicular to AC, CE is perpendicular to AB, and BD is equal to CE. We need to prove that triangle ABD is congruent to triangle ACE and AB is equal to AC. Now proof triangle ABD in this triangle and in triangle ACE, angle A is common for both the triangles and BD is equal to CE, they have already given to us. Angle D is equal to angle E. Why? They are perpendicular to each other. In ABD, angle D. In ACE, angle E, 90 degrees. So the two triangles are congruent based on angle side property. Now since these two triangles are congruent, AB is the side of triangle ABD, AC is the side of triangle AC, they are also equal. So the triangle is an isosceles triangle. Hence, proved, children. Please note it down. Now fifth problem is triangle ABC and triangle DBC are two isosceles triangles. If for this triangle these two sides are equal, for this triangle these two sides are equal. And you have to show that angle ABD is equal to angle ACD. So what is given to us? In triangle ABC, BC is equal to AC. In triangle BDC, BD is equal to DC. And what is RTP? We need to prove that angle ABD is equal to angle ACD. Now let us go for the proof. In triangle ABC, AB is equal to AC. This is given. Therefore, angle B is equal to angle C. Also, in triangle BDC, BD is equal to CD. This is also given to us. Therefore, angle CBD, because if I write B, you may confuse, is equal to angle BCD. Now, angle ABD is nothing but angle B plus angle CBD. Angle B plus angle CBD. Angle B is nothing but angle C plus angle CBD is nothing but angle BCD. So angle C plus angle BCD is nothing but angle ACD. Therefore, angle ABD is equal to angle ACD. Hence, proved. This is the proof for this problem, children. Listen to it. You have two triangles. In this triangle, AB is equal to AC. In this triangle, BD is equal to CD. Now we need to prove that angle ABD is equal to angle ACD. So in this triangle, AB is equal to AC means angle B is equal to angle C. In this triangle, these two sides are equal means angle CBD is equal to angle BCD. So what is angle ABD? Angle B plus angle CBD. That means angle B is equal to angle C, so I wrote angle C plus angle CBD is angle BCD, I wrote. Angle C plus angle BCD is angle ACD. So this is how we have proved this problem, children. Please note it down. Now, theorem 7.4, children. Side congruence rule. In two triangles, if the three sides of one triangle are respectively equal to the corresponding three sides of another triangle, then the two triangles are congruent. So let us draw a triangle PQR and a triangle XYZ. So what is given to you? In triangle PQR and triangle XYZ, PQ is equal to XY, PR is equal to XZ, QR is equal to YZ. Corresponding sides are equal. Now what is RTP? We need to prove that triangle PQR is congruent to triangle XYZ. Now here you have got a construction. What is construction? You have to construct a triangle. Construct a triangle X. Let me call this as W. WYZ. WYZ such that PQ is equal to YW. PQ is equal to YW. Angle PQR is equal to angle ZYW. Angle ZYW means this angle is equal to this angle. Now prove in triangle PQR and ZYW, PQ is equal to WY. It is our construction, and QR is equal to YZ. This is given to us, and angle PQR is equal to angle ZYW. This is also our construction. Therefore, triangle PQR is congruent to triangle ZYW basing on side angle side property. Let us consider this as first equation. Now, let us continue. Now, there is another construction, children. That is, you have to join X and W. Join X and W. If you join X, W, we are getting two triangles here. Let me take this as X, Y, W, or else in this let me take this point as P. P already we have taken. Let me take this point as S. In these two triangles, in triangle SYW and triangle XYS. In triangle SYW and in triangle SYX, we know that WY is equal to XY. WY is equal to XY. Why is it? Because PQ is equal to WY and PQ is equal to XY. Because of this, they have given PQ is equal to XY. We have proved PQ is equal to WY. So these two are equal. When these two are equal, I can say that, I can say here, this one. Let me take this as angle 1 and this as angle 2. Angle 1 is equal to angle 2. If I consider this as angle 3 and this as angle 4, in the same way we can prove. Similarly, we can prove that angle 3 is equal to angle 4. Now, when you talk about angle W is angle 1 plus angle 3. Therefore, angle 1 plus angle 3 is equal to angle 2 plus angle 4. Angle 1 plus angle 3 is equal to angle 2 plus angle 4. This is nothing but angle W is equal to angle X. Angle W is equal to angle X. And XZ is equal to WY. Why is it? Also, XZ is equal to XZ is equal to WZ. Why is it? Because WZ is equal to PR. WZ is equal to PR and PR is equal to XZ, which is already given to us. PR is equal to XZ, it is already given to us. Therefore, what you can say, see in these two triangles, therefore, in triangle XYZ and triangle WYZ, angle X is equal to angle W, and then these two sides XY is equal to WY and XZ is equal to WZ. Therefore, I have no place, children, I am writing here. Therefore, triangle XWZ is congruent to, first I'll write what is written here, XYZ. Therefore, triangle XYZ is congruent to triangle WYZ basing on side angle side property. It is second equation. So in first equation, triangle PQR is congruent to triangle ZYW. ZYW or YWZ is same. So from 1 and 2, we can prove that, see, triangle PQR is congruent to triangle XYZ. This is hence proved. This is the proof of this theorem, children. Once again, I'll explain. See it. SSS congruency rule in two triangles. If three sides of one triangle are respectively equal to three sides of another triangle, then two triangles are congruent. Now in triangle PQR and in triangle XYZ, PQ is equal to XY, PR is equal to XZ, QR is equal to YZ. So you need to prove that these two triangles are congruent. Now there is a construction. What you have to do? You have to draw WY, which is equal to PQ, and angle ZYW, which is equal to angle PQR. When you do this construction, in these two triangles, PQ is equal to WY, our construction. Angle PQR is equal to ZYW, this is also our construction. QR is equal to YZ, which is given to us. So these two triangles are congruent basing on side angle side property. Side angle, this angle and this side property. So these two that are congruent, that is first equation. Next, you have to join XW. This is another construction. XW is intersecting it at S. This point is S. Now, when you are talking about these two triangles, in these two triangles, what you can say, YW is equal to XY. Why? Because PQ is equal to XY, PQ is equal to YW. So these two are equal. And apart, if these two are equal, angle 1 is equal to angle 2. Similarly, in these two triangles, we can say angle 3 is equal to angle 4. So angle W, that is angle 1 plus angle 3 is angle 2 plus angle 4. That means angle W is equal to angle X. This is what I have done. So when these are equal, we can even say XZ is equal to WZ, because PR is equal to WZ and PR is equal to XZ. So these two are equal. That means what? Triangle XYZ is congruent to triangle ZYW basing on side angle side property. So that is second equation. So from one and second equation we can prove that these two triangles are congruent. Please learn it properly, children. So with this, I am going to conclude my topic today. In the next class, I will be doing the next part.